The next thing we're going to do is probably the most important thing that you do in all of chapter 7, which is to simplify radicals. This is the skill that as you go forward in the course, you have to keep it. If you go into Math 60, this is the thing that you're going to be able to do every single time you look at a radical. So what this is that we are going to be putting they call it simplifying radicals. We're going to put radicals in their lowest terms. What that means is looking at a number underneath a radical sign and thinking, is there a perfect square factor of 18? Is there a perfect square factor of 27? Is there a perfect square factor of 240? And if there is, it means that we can simplify it. So if I look at this first one, the thing you have to be comfortable with is your perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 36, 49, 64, 81. What else have I got? 9 squared, 10 squared is 100, 121, 144, and that's generally enough for you to know. But these are our perfect squares. So what are we going to do with these? Well, we're looking to see if any of these divide into 18. So in a dream world, you're finding the highest perfect square that divides into 18. So you would start by half of 18, which is 9, and then going down from there. So now 9 goes in. So what I do, method number 1, is to write the radical as a product of a perfect square radical and a non-perfect square radical. In other words, I'm going to draw two radicals, and I'm going to break 18 up into two numbers that multiply to give me 18, where one of them is perfect square. So 18 divided by 9 to give me 2. And then I can take the square root of 9 to get 3 root 2. And that's a simplified radical. So I took out the perfect square factor. So if I look at the next one, I'm looking at 27. So I'm looking for the highest perfect square in this list that goes into 27. So I would start with half of 27, which is like 13.5. So I would divide by, 9. Well, it went in again. Look at that. So 27 divided by 9 is 3. So the square root of 9 is 3 root 3. Then we get a number like 240, and I don't even know what goes into it. So I want to look for the highest perfect square that goes into 240. So again, I start at half, which is 120. So I start dividing from the biggest to the smallest. You don't have to, but what that does is allow us to find the highest perfect square that goes in so that we can simplify fully. It's kind of like if I asked you to simplify like 8, I'm trying to think of a good example. 18 over, sorry, on the spot, I'm trying to think of a good example. So let's say I wanted to simplify 24 over 40, right? I could simplify this to say 2 goes into both 24 and 40, but then I'd have to go further, right? 2 goes into both 12 and 20. Oh man, and even further. I picked a good example, right? So to simplify, you have to go all the way, whereas I could have said, you know what, 6 goes into both. I could have said 6 times 4 over, wait, does 6 go in? Not 6, 2, 8. 8 goes in. 8 times 3 over 8 times 5. And I could simplify fully to 3/5 in one step. So it's the same idea with radicals. If you find the highest perfect square, you can simplify in one step. If you don't find the highest perfect square, then you have to do it in more than one step. Okay, so for 240, I would start with somewhere around 100. Now I know 100 won't go in, so then I'll go divided by, I don't think 81 will go in, but I'll try. 240 divided by 64. 240 divided by 49, 240 divided by 36, 240 divided by 25 won't work, 16. There we go. So I could say that 240 is root 16, root 15, and then that would give me the square root of 16 is 4 root 15. Now, if you hadn't found 16, maybe you looked at this and went, well, come on, Karen, what are you doing? 4 goes in. Just do 4, Karen. Maybe you're screaming at the screen. Well, you'd go root 4. Let's see, 240 divided by 4 is 60. But then you'd have to go further. So square root of 4 is 2, and then we say what can go in? Oh, right, 60 divided by 4 is 15. So then I'd be left with 2 times 2, which would give me 4 root 15. So I get the same answer. It's just whether I had to simplify twice or whether I could do it all in one step. Now, this is one method for writing radicals or for simplifying radicals. There is another one called prime factorization. I'm maybe going to show it just on a different page. One sec. So I've put a video like of somebody else explaining prime factorization as well, but I just wanted to show you guys. So prime factorization would work that instead of looking for the highest perfect square that divides in, you would break your number up into its prime factors. So prime factors are numbers that are divisible by itself in 1. So it's things like 1, 2, 3, 5, 7, and so on. So what I do is I take 18 and I divide by any of those. So I'm going to say that 2 times 9, and then 9 is 3 times 3. So this is my prime factorization. My prime factorization would be 2 times 3 times 3. And then what you do is you look for anything that is written twice, like 3 times 3, right? That means it was a perfect square, and it would simplify to 3. And so you'd have it kind of like this guy, so that you'd end up with the square root of 3 times 3 is 3, and then you'd still have a root 2. So my simplified version would be 3 root 2. So same thing with 27. 27 doesn't divide by 2, so I'm going to divide by 3. I'm left with 9, and then 9 is 3 times 3 again. So if I look at the prime factorization, I've got 3 times 3 times 3. I have one pair that would give me 3, and then I'd be left with a single root 3. Right? So it's just a different way of looking at it. I've never personally done it this way, but now that I've done it enough times, I'm like, oh yeah, I can see the validity of it, especially with something like 240, because 240 is such a big number. So I would divide by 2 to be left with 120. I'd be divide by 2 to be left with 60. I'd be left with divide by 2 to be left with 30. Divide by 2 to be left with 15. Now 2 doesn't go into 15, so I'll use 3, the next prime, and I'm left with 5. And then you look for pairs. So you can kind of show your work however you want. You know, when I started, I was like, okay, square root of 2 times 2 is 2. Square root of 2 times 2 times 2 is 2. So then I've got these guys would give me 4. And then these ones would be my leftover. So I'd have 4 root 15. Right? So you kind of find your way with it. Maybe I should have shown a little bit more work with that one. Right, so I could have gone prime factorization is 2 times 2 times 2 times 2 times 3 times 5, and then you look for pairs. So that pair would give me 2 times 2, and then these guys are left over. So 3 times 15, and I would be left with 4 root 15. So it kind of depends how you see it. I personally am always looking for the quick way, and I find that this is quickest. But if I was really stuck on one, I'd be tempted to try prime factorization. So now what I want you to do is I want you to pause the video and I want you to try these 3. So I want you to try to simplify these 3 radicals. You can use your perfect squares to find which one goes into these numbers evenly, or you can prime factorize. Give it a go. So for me, I'm looking for the highest perfect square that goes evenly into 8, which is 4, and it's 4 times 2. So then the square root of 4 is 2 root 2. For this one, I'm looking for the highest perfect square that goes into 128. So I'm going to start with half, which just happens to be a perfect square. So half of 128 is 64, and then I'm left with 2, which would give me 8 root 2. And then same thing with this one. If you start with half, it is actually a perfect square, and I would end up with 6 root 2. There are a lot of people, especially when I used to put that one right after these two. You know how 9 went into this one and 9 went into this one? People would always look at this one and be like, oh, root 72, that's 9 and 8. And I'd be like, great. Square root of 9 is 3, but you're not done. You'd have to do, oh yeah, the highest perfect square that goes into 8 is 4. That would leave me with 3 times 2, which would be 6 root 2. So again, you can do it the slow way, which is find any perfect square and then see if you have to go further, or you can look for the highest perfect square. All right. The next thing we're going to look at is simplifying mixed radicals, which if you're someone who's done like this one this way, you've already done mixed radicals. All I want to show you is that the 2 stays out front. You're going to write this radical as a product of two radicals. And again, you're finding the highest perfect square that goes into 56. So I always start dividing by 2, which is 28, not a perfect square. So the next highest perfect square is 25, but that won't go in. So I'm going to try dividing by 16. So 56 divided by 16. Didn't work. So I go 56 divided by 9, didn't work. I go 56 divided by 4, that works. So I've got 4 and 14. And then the only thing I really want to show here, which, I've kind of already shown it, but I didn't make a big deal about it, is that when you take the square root of 4, it's 2. And I say it like that because a lot of people go, oh, the square root of 4 is the square root of 2. Like they don't take the root off. So sometimes a student and I started calling it removing your hat. So as soon as you take the square root, you're taking your hat off. So you're left with just a bare 2. And then you've got 2 times 2 times root 14. So you can multiply the 2 times 2 together to get 4. And then that's still multiplying by root 14, but you can't multiply them because they're not radicals. So try this one. Again, you're looking for the highest perfect square that divides evenly into 32. So I found it was 16 times 2. Then take the hat off. Square root of 16 is 4. And then you're left with 3 times 4 is 12, root 2. Awesome. So building it up, the next level is we got to put variables into it. Now variables look hard, but they're not that bad. You're going to do them the same way where you're going to write these as a product of two radicals. And the nice thing is that because the index is 2, right? If you think about this, this is x to the 3 halves. The reason I can't take the square root of x cubed is because 3 doesn't divide by 2. But I could write this as x to the 2 over 2 times x to the 1 over 2. Maybe that's too confusing to see. What we're going to do is we're going to take the highest exponent less than 3 that's divisible by 2, which is just 2. Okay, so what we did is we broke x cubed up into, so x cubed is x squared times x. Right? When multiplying powers of the same base, you add the exponents. So all we did is took the even exponent less than 3, which is 2. And then the square root of x squared is just x. So don't forget, when you're taking a square root, you're dividing the exponent by 2 because the 2 becomes the denominator of the fraction. All right, so what about this one? What is the highest perfect square less than 7? Or let me put that differently. What's the highest number less than 7 that divides by 2? 6. I'd be left with a y. Then again, this is the square root of y to the 6. So I'm going to do 6 divided by 2 is 3 root y. All right. Try this one. It's got 2 letters, so I just wanted you to do it twice, with 2 different letters. So for this one, the 6 is even, so it's going to come all out. I don't have to put something in this bracket. And for this one, I'm going to do y to the 12, be left with y. So then the square root of x to the 6 is x cubed, right? I divided the exponent by 2. And then the square root of y to the 12 is 12 divided by 2 is 6. I took the hat off because I took the square root, and then I'm left with root y. Then the last thing we're going to do is put it all together. So we're going to have numbers and variables all under the same radical. So again, you just start by writing 2 radicals. Into the first radical, you put all your perfect squares, and then you put your leftovers. So the highest perfect square that divides into 27 is 9 times 3. The highest even number less than 3 is x squared with an x. So then I can do the square root of 9 is 3. The square root of x squared is x. Root 3x. Pause the video and give the next one a try. So again, we're going to simplify 72. You could do prime factorization or not. I do find that the more you do these, they don't ask that many numbers. You'll start seeing some repetition. We've already seen 27. We've already seen 72. So the highest perfect square that goes into 72 is 36, leaves a 2. Highest perfect square that goes into a cubed is a squared, leaves an a. And then the highest perfect square that goes into b to the 4 is b to the 4, no leftover. Then we take the square root of our perfect square radical. So the square root of 36 is 6. The square root of a squared is a. And the square root of b to the 4 is b squared. And then you've got your leftover. And that's as hard as they get. But this skill is very, very important. Not so much with variables past Math 50, but definitely the numbers.